Hi students, problem number 11. A current I flowing through the loop is shown in the figure below. The magnetic field at the center O is to be determined. This one is very interesting problem. You can see here one arc is there, red color arc. This is the smaller arc. And the other one is the blue color arc, that is the PQ. This is a larger arc. The radius of the first circular arc is capital R and the radius of the larger arc is 2R. It is a 2R. So when I ampere of current is flowing in the clockwise direction, what will be the magnetic field at the center O is being asked. Now the clue is here this angle is a right angle. So at this place the angle subtended is 90 degree. So what should be the remaining angle subtended by the smaller arc? That one here it should be. So this angle must be equal to 270 degree. 270 degree is also what, a 3 pi by 2, and a 90 degree also is what, a pi by 2. So this has to be understood first. So the angle subtended by the smaller arc at the center is 270 degree or 3 pi by 2. And the angle subtended by the larger arc at the point O is 90 degree or it is a pi by 2. Okay, now the field due to the first arc is B1 and the field due to the second arc I will take it as B2. Okay, first I will find out what is the magnetic field at O due to the smaller arc of radius R. So by formula this is equal to mu naught I divided by 2 into radius, okay, 2 into radius into theta divided by 2 pi. This is the general formula. Okay, so this is now equal to, okay, this is now equal to mu naught I divided by 2r into theta is what? Theta 1 is equal to what? 3 pi by 2. So 270 degree is written as what? 3 pi by 2. So this is a 2 into, already there is a factor 2 pi. So this pi term gets cancelled. The pi term gets cancelled, is it not? So what are the remaining terms? It is 3 mu naught I. So B1 is now equal to 3 into mu naught I in the numerator. Denominator is 2 into 2, 4 into 2, 8. So this is 8R. So 3 mu naught I divided by 8R. So up to this I hope you must have understood. The magnetic field B1 at the point O due to the current I flowing in the smaller loop of radius R. But the same current I is flowing through the larger loop of radius 2R. Now let the magnetic field be B2. So B2 is now equal to mu naught into I divided by 2 into its radius itself is 2R. Here only you should not do mistake, avoid the mistake, okay. So the radius of the second larger coil is 2R. So twice its radius is 2 into 2R. Okay, into theta divided by what? Theta divided by 2 pi. So this is now equal to mu naught I divided by 4R into, this is pi by 2. 90 degrees is not for the larger arc. So this is pi by 2. So pi will be in the numerator divided by 2 into 2 pi. Okay. So now this is equal to, therefore what is B2 is now equal to mu naught I. So this pi and pi get cancelled. So this is mu naught into I divided by 4. 2 2s are 4. 4 into 4 is 16. So this is 16R. So this is mu naught I by 16R and B1 is 3 mu naught I by 8R. Okay. Therefore what is the net field? Okay. Therefore net field, okay. Net magnetic field at O. Net magnetic field at O is B is equal to B1 plus B2. So I am going to add these two, B1 plus B2. So this is now equal to what? Therefore what is B is equal to 3 mu naught I by 8R. So this is 3 mu naught I divided by 8R plus mu naught I divided by 16R. So this is mu naught I divided by 16R. So the common factor is mu naught I by 8R. Mu naught I divided by 8R into, here is 3 plus here is 1 by 2. So this is equal to mu naught I, okay, mu naught I divided by 8R into 3 plus half is 3 and a half. So it is 7 by 2. Therefore the resultant field B must be equal to 7 mu naught I. 7 mu naught I divided by 8 2s are 16. So this is 16 into R. And since the current is flowing in the clockwise direction here, clockwise direction, the field will be inward. The field will be into the plane of the board or into the plane of the paper. So this will be inward. Now X is the direction like this. So this is the indication for what inward magnetic field. So which is the correct option? Let us see now. So 7 mu naught I by 16 R inward. So this is the right option. Therefore what? Therefore option A is the correct answer. Okay. Have you all understood? Fine. Hi students. Problem number 12. An electron is moving in a circular path under the influence of a transverse magnetic field, that is perpendicular magnetic field, of B equal to 3.57 into 10 power minus 2 Tesla. If the specific charge of the electron, that is E by M ratio of the electron, is 1.76 into 10 power 11 coulomb per kilogram, then the frequency of revolution, okay, the frequency of revolution of the electron has to be determined. Now in all such problems, wherever charged particles are moving inside a transverse magnetic field, the Lorentz force is equal to the centripetal force. Direct equation you can substitute, that is the period is equal to 2 pi m by qb, and the reciprocal of the period is the frequency. Understand? qb by 2 pi m directly. But still I will give you how to derive the equation once again. So here q V B is equal to M B square by R. So this V and power get cancelled. So this is Q into B, that is QB is equal to MV by R, M into V by R. Therefore V by R, therefore the ratio V by R, okay, V by R is equal to QB by M, QB divided by M. So here this Q is the charge of the electron, is it not? Because the particle is electron, its charge is E. So instead of Q, I am going to substitute E, so that this will become E by M, E by M into B. So this will be E divided by M, charge by mass, specific charge, into B. Okay. Now the period is equal to 2 pi, okay, 2 pi into R divided by V, and the frequency is equal to V divided by 2 pi into R. So this is equal to 1 divided by 2 pi into V by R. So this is a V divided by R. Now instead of V by R, I am going to substitute what? E by M into B. Therefore the frequency is equal to 1 divided by 2 pi into E by M into the magnetic field B. So this is the substitution I have done. Okay. Now the value 1 by 2 pi is 1 by 2 pi. If you substitute means you will get 0.16. So this is 0.16 into E by M ratio is how much is given? Charge versus mass ratio, that is 1.76 into 10 to the power of plus 11 into the magnetic field is 3.57 into 10 to the power of minus 2. So I am going to multiply 0.16, 1.76 into 3.57. Okay. So first 0.16 multiplied by 1.76 into 3.57. The product is now equal to 1.005. So this is 1.005 into 10 power 11 minus 2 is okay. So this is 10 power 9 hertz. 10 power 9 hertz. Therefore, this frequency is nearly equal to 1 into 10 power 9 hertz. That is equal to 1 gigahertz. Okay, 1 gigahertz. So, which of the following options? Option A itself is correct, is it not? That is 1 gigahertz. Therefore, option A is the correct answer. I hope you have understood.